Alright, so today's work is on 2B, on the discriminant. So for the record, the discriminant is represented by that symbol. Do you know what it's called, that symbol? Triangle. Delta. Delta is a letter in the Greek alphabet, alpha, beta, gamma, delta. So it's like the D in their alphabet. And so the way I remember it is that the word delta starts with a D and the word discriminant starts with a D. So delta is discriminant. And it's B squared subtract 4AC. Now you think about the word discriminant just in language, in how you might use that. What word does it also sound a bit like?
Discriminate.
To discriminate, yes. What does that mean if we discriminate?
Be mean.
Discriminate. To be mean, okay. Well, to separate things, to discriminate against, to grouping, that sort of thing.
Segregation.
Segregation, sure. So the discriminant helps us to discriminate against something to do with quadratics. And it's to do with the roots, to do with the x-intercepts, the zeros, all of those words. And there's 3 different versions, 3.5, that could happen here. So when the discriminant is greater than 0, equal to 0, or less than 0. So that's the part under the square root sign in the quadratic formula. So you're thinking a square root, what could happen to that? If it's equal to 0, less than 0, what happens just mathematically when the square root of a negative number? What happens there? Let's have a look through these. If it's positive, so you're going to get the square root of a positive number, which is possible. That can happen. Then you would get 2 distinct real roots. So the graph of that quadratic, because you've got 2 answers, would have 2 x-intercepts, 2 roots. Why am I saying 2? Because one's the positive version and one's the negative version. You know where you do the plus or minus sign? So that takes that into account. If it's equal to 0, you've then got the square root of 0, which is 0. Square root of 0 is 0. So the only part you're left with then in the quadratic formula would be this minus b on 2a. There. So that's the only solution. And algebraically, that comes out as a repeated root, or perfect squares, that sort of thing. You might have x take or plus, doesn't matter. I'll use k for a number squared. So you get a factor like that, a repeated factor, the k, x plus k or x plus k all squared. And visually, what does that look like? That's a touch. So that parabola would come down and touch the x-axis, and so it's only got one x-intercept, or could go that way around. So if you get the discriminant equal to 0, you'll only have one root, and it's repeated. So it happens twice in that sense, but at the same spot. Less than 0, you would get the square root of a negative number, which is not real. Have you done some work with imaginary numbers? That the square root of -1 is I. We'll get into more depth in that down the track. But that means visually, it can't be done. So that parabola, if you've got a graph like this, doesn't have any solutions, no x-intercepts. So it can sit completely above the x-axis or completely below. That's what that would look like. So you can, from the discriminant, you can discriminate lots of different things about the graph before you've ever drawn it. The extra 2 things to add, this number here that you get, if you get a square number, so we're talking things like the square root of 4, the square root of 25, the square root of 81, those sorts of things, then that square root will simplify down quite nicely. So therefore, in the quadratic formula, you're left with, say, minus b plus a whole number, an integer, divided by, that'll be an integer down there as well. And they can be factorised by other methods. So the sum product, cross multiplication, one of those easier methods. If it's not a square number, you're going to get, say, the square root of 17 or any other square root of 30, something like that. That's when you will need the quadratic formula to help you factorise. So what we've got there is if delta, the discriminant, is squared, then the equation has two rational roots. So rational is the word that we use, I guess, when it all works out. What would be the word then for these ones? Irrational. Irrational, that's right. So you can tell it's got two intercepts. So the graphs of those would have two x-intercepts. In the square one, they'll be whole numbers, rational numbers. But if the discriminant is a number that's not a square, you'll still get two x-intercepts, that's not a problem, but they'll be irrational numbers because you'll have the surd in them. So moving on to some examples here. It's asking us to use the discriminant to determine the nature of the roots. So discriminant, write that down, b squared minus 4ac. A tip that I find really handy for each question, before you even get started, is to write out your a, your b and your c. So you might write them off to the side. So a here is 2, so it's the coefficients, -2, don't forget your negative signs, and 3. Or, just getting ahead of myself here, sometimes it's handy to write them directly underneath. We've got 3, b is -4, and c is -2. So working out the discriminant for this one, substitute in -2 squared, take 4 times 2 times by 3, and that gets us -20. Doesn't matter how big or small the number is, all we're interested in is the sign. Is it a positive or a negative number? It's negative, so we say the discriminant is less than 0. So that meant if you were to do the quadratic formula on this, the bit under the square root sign would be -20. And so that means it's not going to work out because the square root of a negative number. So what did the question ask us? Determine the nature of the roots. So we say, therefore, no real roots. It means that graph would be, or we don't know, completely above or completely below the x-axis. We're going to get into more depth on that next week. And it does have roots, but they're imaginary roots. So we're not going to go into depth on that today, but there are no real roots is what you need to say. This one, when in doubt, write out the formula. So you know that off by heart. B squared, very handy to have the brackets there to make sure you counteract that negative. Otherwise you'll get the wrong answer. That comes out to be 40. And is that number positive, negative, or 0? Positive. So you say the discriminant is greater than 0. Therefore, how many roots will it have?
2.
It will have 2. And rational or irrational? You look at that 40 number. Is 40 square? No. So I might just put that off to the side, not square. So we can say 2 distinct or 2 real roots, but I'm also going to add in the word irrational. 2 distinct irrational roots. Yeah, so that's how we answer that one. So our last example here is we have to consider this equation. You may or may not see that we have an m in this equation here. We're asked to find the discriminant and work out if the equation has, well, for what value of n will it have the different scenarios. So first of all, I'll write down the formula. And I'll write down what my a, my b, and my c are. A, coefficient of x squared there is 1, b is -2, and c is m. Don't be put off by that. Slightly different. Let's work this out. The discriminant is equal to b squared, that's -2 squared, take 4ac, where c is m, and that's 4, take 4m. So now there's 3 different scenarios. What values will m have if we have a repeated root? What will delta be for a repeated root?
Well, it's equal to 0.
It will be equal to 0, that's correct. So this is actually just going to be some solving equations. Well, the first one, so here's A down here, the discriminant would be equal to 0. So that means we can put that expression equal to 0 and solve for m. So we would get, well, whichever way around you want to do that, minus 4 equal to, well, I'm taking it over to get rid of the negative, and m is equal to 1. So if your m number on the m here was 1, that means the discriminant part, the delta, the whole thing would come out to be equal to 0 if m was 1. You could check that by substituting in if you wanted, and therefore we would have repeated roots, and it would touch the graph. Two distinct real roots. Oh, hang on. What does the discriminant have to be for that? I'm just going to rub that off.
Positive.
Positive, that's right. And positive is greater than 0. Don't be put off by that. We're solving an inequality, and that's okay. So we take this again. This is the one we're going to keep coming back to, and solve for m. You have 4, subtract 4m is greater than 0. Oh, might just have to be a little bit careful here. Do you remember your inequality rules? So I'm going to bring 4 to the other side, so subtract 4 off. Now what should I do? To solve for m,
Yeah.
I would divide through by negative 4 to get positive 1. But what will the sign be?
Greater.
Greater than.
Less than.
Or less than.
It's less than.
It's less than. Because when you multiply or divide through by a negative number, it changes the sign. You may or may not know that. Fact for you for today. Thought you'd know that. No real roots. So that means the discriminant would have what value?
Less than 0.
Less than 0. So you're solving an inequality facing the other way. That whole thing is less than 0. Solve for m. Same rule applies. If you divide 4 times through by a negative number in an inequality, the sign changes. So now, for values of m greater than 1, that's what you would get for your discriminant. Okay.